For today's video, we will talk about motion, particularly on how this term is conceptualized by two known personalities in science history. But before we begin this lesson, I want you to think critically for the following quotations. Number 1. By denying scientific principles, one may maintain any paradox. Number 2. There are those who reason well, but they are greatly outnumbered by those who reason badly. What can you say about these quotations? For number 1 quotation, this means that when someone's belief is more important than the truth, then one holds a paradox. Paradox means a statement or prepositions that is senseless or logically unacceptable. For number 2 quotation, its meaning is already revealed in the quotation, which literally means that no matter how you reason logically and scientifically, if your ideas are not supported, it will be senseless in front of many people. Do you know who is the author of this quotation? He is none other than Galileo Galilei. Did you know that Galileo is the father of modern science? How did he able to earn this credit? As we go on in this lesson, you will learn how. I want to show you this concept map. What is the concept map all about? This presents the different ideas on how our universe is viewed beginning from the Greeks until the modern times. I am presenting this for you to have an idea on how the early scientists viewed the universe, the earth, and of course, motion. This will help us recognize its connection with our competency for today, because at the end of the lesson, you must be able to compare and contrast the Aristotelian and Galilean conceptions of vertical motion, horizontal motion, and projectile motion. Because at this time, we are acknowledging Newtonian concepts of motion. That is why we have the 3 laws of motion. But we cannot deny the fact that the works of the early scientists contributed to these laws, especially Galileo. Let's have a quick glance of the concept map. We all know that the universe is being viewed as geocentric and heliocentric, along with the other views like fire as the center of the universe. So we have pyrocentric model, and the combination of the two views as suggested by Tycho Brahe. Of course, we know that when we say geocentric, the Earth is the center of the universe, while heliocentric means that the Sun is the center of the universe. Why am I presenting this? It is because through these models, we can easily determine the proponents and what type of concepts they would like to present. In short, let us know what type of ideas are suggested by Aristotle and Galileo when it comes to the universe, the earth, and of course, motion. Aristotle strongly adhered to his belief that the earth is the center of the universe. He believed in the celestial spheres, the prime mover, about perfection, ether, terrestrial realm, and celestial realm. By this, he have conceptualized the different models of the earth or the terrestrial motion. We have the natural motion and violent motion, in which Galileo is strongly opposed. Aristotle have his own concept about horizontal motion, vertical motion, and projectile motion. And these concepts lived for 2,000 years, and this idea during the medieval times were highly adopted by the Roman Catholic Church, in which the prime mover was considered as God and the sphere of firmament as heaven. In the case of motion, Vertical motion is equivalent to natural motion. Horizontal motion is equivalent to violent motion. For projectile motion, Aristotle's theory is that projectiles were pushed along by external force which is transmitted through the air. Let us look on Aristotle's concept of motion by doing this activity. Bring out your notebook and pen to answer the following. Imagine that you are presently living during the time of Aristotle. Formulate a hypothesis in each of the following situations. Situation number 1. A rock thrown upward eventually fall downward towards the earth. Number 2. A sheet of paper and a book thrown simultaneously at the same height. Number 3. Pushing and pulling a book forward and backward using your hands. And number 4. A stone thrown 3 meters away. What are your hypotheses? Let us see. You might have the following hypothesis. For number 1, a rock thrown upward will fall to the ground because it seeks the earth, where earth is its natural place in the universe. For number 2, a book will reach the ground faster because it is heavier. And for number 3, force or the push and pull is required to set an object in motion. And for number 4, external force causes the stone to move forward, then fell straight to the ground. Let us compare the idea of Galileo and Aristotle. Let us know how Galileo completely opposed Aristotelian concept of motion. In the number 1 situation, using Aristotle's concept of vertical motion, one may say that a rock thrown upward will eventually fall down because it seeks its natural place in the universe. It seeks the earth, believing that it is its natural place. Same is true with light objects like fire, smoke, and air. It goes upward because according to Aristotle, its natural place is the heaven. For Galilean ideas about the nature of motion, according to Galileo, in the absence of friction, all objects can move freely in space. This is why, at this time, we have frictional force not only between two objects which are solid, but it is also applicable between fluids, whether in the gas or liquid form. This information we're not able to realize during the time of Aristotle. It's Galileo who would able to conclude that when friction is removed, all objects in any form can move freely in space. Let's move on to number 2 situation. During the time of Aristotle, one may easily conclude that heavier or more massive object tends to move faster downward. Here, we can say that Aristotle believed that acceleration is dependent on mass. But for Galileo, according to him, object's speed does not depend on mass. Acceleration depends on time of fall. This idea was conceptualized by Galileo by doing several experiments of falling bodies, including rolled steel balls of different weights on an inclined plane, and using two spheres of different masses from the Leaning Tower of Pisa. And in 1971, an astronaut named David Scott performed similar experiment on Moon's surface using a feather and a hammer. And then, he dropped these two objects on the Moon's surface. And he found out that both objects reached the surface of the Moon at the same time. 3 situation where a book is pushed and pulled, we can say that due to the lack of experiment and resistance to welcome new knowledge about motion, the idea that a force is needed to start an object to move lived for over 2,000 years. As for Galileo, according to him, force is not required to start an object to move. Instead, force is needed to stop an object to move. Galileo asserted that if friction was absent, an object would continue to move with constant velocity. It would continue its state of motion unless push or pull compels to change that state. This idea was proven correct and was supported by Isaac Newton. This is stated in the first law of motion or the law of inertia. For number 4 situation, in the case of the stone which is thrown 3 meters away, Aristotle believed that projectile motion moved in a straight line because of the external force which is transmitted in the stone. Projectiles means any object launched into the space. So according to Aristotle, projectiles were pushed along by an external force which is transmitted through the air. Medieval successors of Aristotle internalized this force in the projectile itself and called it impetus. Impetus means a force or energy that permits an object to move. This impetus caused the object to move in a straight line until it was expended, at which point the object falls straight to the ground. And as for Galileo, projectile motion moves in two-dimensional motion, which is very opposing to the idea of Aristotle. According to him, these are the horizontal motion and vertical motion. That is, of uniform motion, meaning to say it's constant in the horizontal direction, and uniformly accelerated motion, meaning to say it's changing in the vertical direction. Newton expanded the works of Galileo to better define the relationship between energy and motion. Thus, we have a richer understanding now of velocity, acceleration, force, inertia, and momentum. And more importantly, through the experiments done by Galileo, Newton was armed with theories of dynamics, so the idea of gravity arose. Now that you have a better understanding about vertical, horizontal, and projectile motion, you may now accomplish the following activity. Compare and contrast Aristotelian and Galilean views of motion by putting the concepts in its appropriate part of the diagram. You may now start. Let us check your diagram. For your quiz, tell whether each statement suggests Aristotelian or Galilean idea of motion. I'll give you time to answer these questions. Your time starts now. Let us check your answers. For your assignment, read about how Galileo concluded that objects allowed to fall in a vacuum will have a uniform acceleration. And That's all for today, class. I hope you have enjoyed our class today. See you next time. Bye!